Hi everyone, welcome back to our channel. In today's tutorial, we are going to learn about an interesting concept called tool server in Open WebUI. To make this simple and practical, we have built a small tool server built on FastAPI. So it does some small currency converting operation actually. So this server is completely written in FastAPI. So we exposes two endpoints. One is the health endpoint, another one is the convert endpoint. Health is written just to see if the server is running or not, just to check. And the other is the main convert endpoint actually. So this is where we send an amount and two currency codes like USD, INR, and it will return the converted value. So this server talks to two possible data sources. So the one is this one, Frankfurter API for live exchange rates. So this is a free API. You can get the live exchange rates for free without any API key. And for example, if this Frankfurter API fails, then we are going to use an ECB JSON mirror hosted on this JS deliver. So this is a static page. You get some currencies, but these are not live. So it's clean, a minimal setup that demonstrates how a tool server can wrap external APIs and expose them in a standard way for a Open WebUI call. So before going ahead understanding about the main core concepts of this tool server, let's do a quick demo about how this tool server actually works. Let's do a quick demo. So here I opened this chart. So I have chosen this model DeepSeek v3.0 and set this function calling to native, and let's ask some basic question like can you convert some 220 United States currency to Australian currency? So we are asking this question and we expect it to call the convert function from the tool server. So it is executing this tool and it has got the result from Frankfurter API. So without a fail. So this is $220 USD and the final written code is AUD. It has taken accurately and this is the rate. And what is the live rate today? So the live rate today is 1 USD is equals to 1.52 AUD. So it has taken more or less nearly. So we have got this much 220 USD as 333 AUD. So this is the main fundamental working mechanism. This is how we have to use this tool. That's it. Unlike in a standalone tool, you have to choose your specific tool actually. But in tool server, you no need to choose your tool server. If your endpoint is running, if your server is running, and you have linked that server to the Open WebUI interface, and you can see all those endpoints available here. And based on the description we provide in the tool, so it automatically decides which one to call. Okay, so the LLM quickly call that function and gets the work done. This is how basic tool server works actually. So before going ahead, let's understand some fundamental differences between the standalone tools and these tool servers. What are the advantages of using these tool servers? Earlier, we have written some standalone tools, right? So those we have written something like this. So this is our earlier standalone tool that does web search on archive.org. Okay, so this is a standalone tool, and this is our tool server that does some currency operations. So if you have look, one of the fundamental differences between this standalone tool and this tool server is for this standalone tool, the code lives directly in the Open WebUI environment. That is fine when the function is very small, like parsing some text or doing some quick math calculation or fetching some file. If it's a small operation, that's fine. But the moment you need some external APIs, this is a small Frankfurter is a small API, but imagine like you have to use multiple APIs or you have to run some longer running tasks or some special libraries. The code becomes very heavy and the UI gets cluttered actually. Standalone tools are tightly coupled to the Open WebUI interface and Open WebUI environment. So they are not very flexible if the logic grows big and the functionality of the tool grows big. This is where the tool server comes, and this solves the problem by keeping the logic outside of this Open WebUI environment. So this is our Open WebUI environment, right? So this is where our standalone tool is running. But if you use a tool server, so it runs outside of this environment and it runs in any environment actually. You just have to connect it to your Open WebUI via some endpoints. All the API calls, conversions, data handling happens inside this fast API server or in any other backend actually. Open WebUI acts just like a client, making a clean HTTP call. That's it. This separation is very powerful because you can restart, update, or even replace the entire server code without touching Open WebUI. But earlier in a standalone tool, it's not the case actually. You have to actually put your code directly in this toolbox. You have to actually modify your code here if you opt for a standalone tool. But in a tool server, you don't have to do that. You can just change your code directly in the notepad file or in any other editor of your choice and just restart the server. That's it. And another thing is it also makes the testing very much easier. Like you can directly hit the server endpoints with curl or postman and you can test your API. Another big advantage is scalability actually and reuse. If tomorrow you want to run the same currency converter for many users, for say some lakhs and millions of users, you can deploy the tool server on the cloud and any number of Open WebUI instances or even other apps can connect to it actually. With the standalone tools, the logic is locked inside this Open WebUI process and cannot be reused easily. With the tool server, it behaves like a proper microservice which you can plug into different projects. So the rule is simple. If it's a small helper function or it's a small utility, then go with a standalone tool. But if it's a serious feature that talks to external systems, needs scaling, or you think of reusing it in another projects, then always build it as a tool server. So that's why in this tutorial we are using this tool server pattern for the currency converter, because once you understand this pattern you can apply it for any bigger apps like weather, stocks, databases, or even sometimes you can create your own business APIs. So that's not a problem. You can fetch data from any API or any URL and you can expose it to any API via endpoints and you can access them in live in this Open WebUI. And another important aspect is in a standalone tool, we have this clear class called tools. And in a tool server, we don't have anything like that actually. In a tool server, this fast API server itself is the tool. We just expose endpoints like what we are doing here actually. Here we are exposing two endpoints. One is the health endpoint, another is the convert endpoint. So this fast API automatically generates an open API schema. Open WebUI reads that schema, so we don't have to write any tools class inside the UI of Open WebUI. You don't need to write anywhere about the tool that you are using. You just have to run your server and you have to connect it. We will see how to connect it in a shortly. So, and one common doubt that people most often gets is how does the LLM knows which tool to call? So if you look at here we have in this tool, so we have two endpoints available, health and convert. And likewise, if you server is big or if you have written multiple tools and if you are exposing many functions, then you will have more endpoints here actually. So in that case, how does your LLM knows which specific endpoint to call? It's actually is very simple actually. Along with the Open API's schema, we also give some clear description to each endpoint actually. So this is the clear description and it is very important. So here we have written a short one, but you have to give it a longer so that LLM can clearly understand what to pick for what kind of functions. Okay, that is what is here actually. It is a quick service health check, returns JSON with service status, name and version. And here we have written perform currency conversion, that we have written here actually. Okay, and this is this function description, and that is what is exposed here, and this is what is available to LLM to decide which tool to call for what purpose. Okay, next, after you write your fast API server, you just have to run it and keep the server alive actually. So for that, we have to use this UICon server, and you have to specify this port and you have to run this command. So here we will be running like this actually. So this is UICon, this is a file name fx tool server v2 colon app, and this host 000 port I'm giving as 8001. So when you click it, and this one UICon is running on this server, you just have to copy this, and then you have to go to your Open WebUI interface and you have to click the settings. And if you go to settings, just below this connection you see this tools actually. So you see this manage tool servers, you just have to give that here. So that's what I have given here. I have specified as HTTP is to localhost 8001. That is what I have specified here actually. 8001 is the port ID that we just given here. If not, for easy remembering, you can give something else like 8002 or 8003. The only thing is you should not reuse the port of something else actually. So you have to make this port unique and not used. Keep that in mind, and you can choose any number. Give that here actually, http colon slash slash localhost is to 8001, and this openapi.json is always there. And after specifying just this open api.json will automatically come, meaning it is added by the Open WebUI itself. And since we are creating this API, so we don't need to give any API keys actually. For example, if you are if you are using some other API keys. So for example, if you are availing this tool server from some external vendor, then they may give you some API keys to access their tool server. So in that case, you have to provide your own API key. Okay. The best part is after creating this tool server, if it works well, you can sell this, meaning you can sell your API keys to someone else for some money. Okay, after giving this and clicking here, you can just save it. Once you're done, you will see this message setting saved successfully. After that, you can close this, and after that you can close this. Then open any new chart. Make sure you turn this function calling to default, and then after connecting that endpoint, you will see all of the tool servers that are running here actually. In fact, you can give any number of tool servers that you want. You can connect to any number of tool servers that you want. There is no limit on it. Okay, so all the endpoints within each tool server will be listed here, and you don't need to explicitly choose a specific tool server that you want. LLM will automatically decide what to call based on the function description. Okay, and then if you give it, so what is the today's currency conversion rate between 1 USD to AUD? So we just asked some question, and it is expected to use this currency conversion tool that we have just built. As of today, the currency conversion between 1 USD is equals to 1.59 AUD. So what it took, this is the schema. So it took the amount as 1 USD to AUD like that, and it used this Frankfurter. So if it fails, it uses the ECB fallback. So eventually you get the answer. That's how this works actually. Okay, let's go into the main code. So here I have clearly written the main description that we need to understand this entire code. So basically, in order to run this tool server, you need these three requirements. I have installed them in this VideoGen Python environment. See, our Open WebUI is running in this Open WebUI environment, but our tool server is running in another VideoGen environment. And then after installing this libraries, I just have issued this command uicon server app host and some port name. Okay, and if you want to test your API, you can use this curl endpoints, or you can use your postman also to check whether these endpoints are working fine or not. Once you confirm your endpoints are working fine, then you can use any prompts like this: convert 100 USD to INR, what is 75 euros in GBP, like that. Okay, here I am importing the necessary libraries, and here I'm giving some application metadata like app title is the currency converter, and app description something like convert between currencies using Frankfurter, and app version. So this is my second version. first version I have built it for test purpose, and this is my final version that I am demonstrating here. And these variables I am giving it here actually app instance. This is basically a metadata. You don't need to worry about it. And here I am giving this course middleware. For this tutorial, I kept the course wide open. So for now, I kept this stars so that anybody can use or any front end can use. But in production, you have to restrict this to calls from certain specific domains. And then here I have written this main class. So this is our base class, you can say. Okay. This is a pydantic model. Basically, whenever you post to this convert endpoint, your JSON body has to match this model actually. So this model consists of these things. Amount is a float variable, and we have a code. From code, it's a string, and we have a to code that is also a string. And here I have given a validator. Validator means sometimes we get these codes in the small letters actually. In that case, this upper function will convert the lower class string to the upper class, means all caps. So that's what it does actually. And next is this convert core function. So this is the main function that is heart of this project. This is where the actual conversion happens actually. So here I have written two paths. So the first one is to get the conversion happen using this Frankfurter API. And for example, if this one fails, so we are asking to use this CDN.js deliver. So here in this JSON, we have got some currencies. I don't know what and how they maintain this, but you can get the live currency conversion rates actually. I don't know whether they are live or not, but you get the currency conversion rates. So if this Frankfurter API fails, then we use this one. If this also fails, then we return this one, none. Okay, these are the three things that were written here. And this Frankfurter API, we don't need any API keys, but ideally in production environments or some other complicated applications, so you need to actually use API keys actually. So those you have to provide, and you can define here as well. So there's no problem. And once we define our main convert core function, here I'm exposing two endpoints. One is health and another one is convert. So health is a get request, and this convert is a post request. Okay, this health, what it basically does is, if you go to this URL in your browser or hit with curl, it just replies like status OK, service, app title, and version. So it just replies this actually. So this tells us whether this server is live or not, and you can basically access it or not. Okay, and this one, the convert endpoint. So this is the main real endpoint. So we post our JSON body here. FastAPI validates it against this convert in class. Okay, so basically the inputs are matched against that class. If they are good, then it will accept, and then we send the data like this, and we get the response also in the direct format, like from code to code, amount, converted amount, rate, etc. And the provider, if it's a Frankfurter, we return a Frankfurter. If not, we write ECB fallback, and if not, we write conversion failed actually. So that's it. That's the overall tool server. So there's nothing complicated here actually. It's just a normal fast API server. You just run it and access it via your Open WebUI. Okay, if everything goes well, so it basically works like this actually. Whenever you write a prompt like this, okay, this Open WebUI calls this convert function, and then it goes to this convert endpoint, and here the fast API checks whether the input is valid or not. Okay, once this input validity check completes, it calls this convert core with the appropriate data, and then this convert core will return a JSON like this with this data, and this will be returned back to this Open WebUI like this, and this information is used in formatting this answer. Okay, this is how the basic tool server works. Okay, hope you understand the fundamental differences between the standalone tools and the tool server, right? If you have any questions or suggestions, feel free to write them in the comment section. See you in the next tutorial. Thank you. Happy learning.